Okay, 3.4, transformations of cubic and quartic functions. So as a recall, transformations are in this form, y equals AF k, x minus d plus c. Okay, and just as a recall, A is a vertical stretch or compression, and if it's negative, it's going to be a reflection in the x-axis. K would represent a horizontal stretch or compression. And if K is negative, it's a reflection in the y-axis. The D value is a left-right, and a C value is a up-down translation. Okay, and this is how we do the mapping notation. We are back to this. Okay, example 1. State the transformations that must be applied to the parent function to graph the following. So first of all, the parent function for this is x cubed. Okay, we have y equals -2, x minus 1 cubed plus 3. Parent graph is just x cubed. So we have to go through each of these transformations individually and list what's going on. So the negative sign, this is a reflection in the x-axis. The 2 is a vertical stretch by a factor of 2. Okay, the 1 is right 1 unit. You can also say horizontal translation, right 1 unit. And then the plus 3 is up 3 units. Okay, and now number 2 says sketch the function using mapping notation. So what we're going to do is we are going to start with an x and a y, and then we're going to go ahead and use mapping notation to transform it. So I'm going to go -2, -1, 0, 1, 2. -2 cubed is 8, -8, -1 cubed is -1, 0, 1, 8. Okay, as a review, reflection in the x-axis, if it's reflected from up to down or down to up, we're actually affecting the y numbers, like these numbers here. So this affects the y. Anything vertical, when we think vertical, we think the y-axis. So again, y. Right, left, right would be the x-axis. So this transformation affects the x values. And up 3 units, again, up and down, that's going to affect the y. So if our x is moving right 1 unit, this is x plus 1. If our y is reflected and stretched, we'd have -2y, and then up 3 units plus 3. And we are going to take every x value in this column, and we're going to sub it into x plus 1. So -2 plus 1, -1 plus 1, 0 plus 1, 1 plus 1, 2 plus 1. And now we're going to take every y value and we're going to sub it into this y here in this expression. So -2 times -8 is 16, plus 3, I get 19. -1 times -2 is 2, plus 3, I get 5. 0 plus 3, I get 3. So subbing in 1, I get -2 plus 3, which is 1. And subbing in 8, -16 plus 3, I get -13. And now we can go ahead and graph. So -1, 19, 0, 5, 1, 3, 2, 1, 3, -13. And we can connect these. We know it's an x cubed, so we know it flattens out in the middle there. Okay, and don't forget to label your graph and put arrows on each end. So for B, I want to make a note. Some functions can be simplified before graphing. So look for functions with both stretches and compressions. So I'm going to make a note over, just to the right of the page. If we took a look at the A value here, which is 8, this is a vertical stretch by a factor of 8. And if we look at this k value here, this is actually a horizontal stretch by a factor of 2, right? Because it's always like 1 over k, it's always the reciprocal. So we could plot it with 2 transformations and that would be fine. I'm going to show you another way. We can actually simplify this before we graph it. So as an example, what I'm going to do is I'm going to factor out this this 1/2. So I'm just going to common factor it out of here and common factor it out of here. So we get 1/2 being the common factor, and then we're left with x plus, and if you think about like 1 divided by 1/2 is 1 times 2 over 1. So x plus 2, and that's all to the exponent 3. Okay, so that was just a common factor. So what actually happens is we can take this 1/2 and we can cube it. And then we can take this x plus 2 and leave that cubed. So if we took the 1/2 and we cube it, it's actually 1 over 8. And then I'm just going to transfer everything down, x plus 2 cubed minus 3. So these cancel out. And we end up getting simply x plus 2 cubed minus 3. This is much easier to work with. This is, for transformations, this is left 2 units, and this is down 3 units. Okay, so mapping. We're going to write the x and the y for the parent function, which is y equals x cubed. We can sub in -2, -1, 0, 1, 2. And we're going to get -8, -1, 0, 1, 8. So now this is easy. Left 2 units, we're going to take every x and we're going to go left 2 units. So x minus 2. That affects the x. Down 3 units affects the y. Say y minus 3, because we're going to go down 3. So we're going to take every x value and we're going to subtract 2 from it. So I get -4, -3, -2, -1, 0. And we're going to take every single y value and we're going to subtract 3 from it. So -11, -1 minus 3 is -4, that's -3. 1 minus 3 is -2, and then 8 minus 3 is 5. Is that positive? Nope, that's good. Okay, and now we're just going to graph. So -4, -11, -3, -4, -2, -3, -1, -2, and 0, 5. Okay, and remember it's going to flatten out here in the middle, right? Because we know that our x cubed looks like this or like this. That's very, very elongated. Okay, and then just label the graph, and you can label it with either function. This one down here or the original, because they are equivalent. Okay, the function y equals x to the 4 has undergone these transformations. So vertical stretch by a factor of 5, reflection about the y-axis. So, okay, vertical stretch, verticals up and down, so that's going to affect the y. A flexion about the y-axis, if you actually think about the y-axis, we're going from like left to right over the y-axis, so that affects the x values. Horizontal stretch by a factor of 4. So horizontal is left, right, so that's x. And then horizontal translation to the left 2 units, so again, x. Okay, so the question asks, if f at x equals x to the 4 passes through these 3 points, list the new coordinates of the transform function. Okay, so this has well more than like one step here. So I would say that I would first write an equation for these transformations on x to the fourth. Okay, so f at x equals vertical stretches first, that's the a value. And then this, so since it's a horizontal stretch by a factor of 4, it's actually 1 over k. So this is going to be 1 over 4. But there's also a reflection in the y-axis, so that's negative 1 over 4. Okay, horizontal translation, left 2 units, so this is going to be x plus 2. And then this is going to be to the exponent 4. So we're not going to simplify this one, but instead of doing the points for x to the 4, instead of going down like the x column and subbing in negative 2, negative 1, 0, 1, 2, what we're actually going to do is we're just going to look at these points here and say, okay, well, the points that we're using are negative 1, 1, 0, 0, and then 2, 16. We are missing points in here. They don't have to be consecutive. This question's only asking for these specific 3 points. So this is our k value. So we know that our mapping is, for the y, it's ax plus c, and for the x, it's x over k plus d. Okay, so x over k means take the reciprocal of k. Instead of being 1 over 4, we would have 4. But it is negative, so we keep that. Negative 4x minus 2, because we're going left 2 units. Now we have 5y here. We don't have a c value, it's plus 0. So all we have to do is we have to take these 3 values and we have to put them into this x value. So negative 4 times negative 1 is 4 minus 2. 0 minus 2, and then negative 4 times 2 is negative 8 minus 2, I get negative 10. Okay, take all these values, plug it into the 5y. So 1 times 5, 0 times 5, and 16 times 5. That's one for the calculator. Here we go. So, list the new coordinates. Therefore, new coordinates are 2, 5, negative 2, 0, and negative 10, 80. Okay, example 3. Determine the x-intercepts for each of the following. So initially when we're looking at this, students may think that this is factored, but it's not. Okay, as soon as we have another term like plus or minus beside it, this is no longer factored. This is kind of in like a vertex form type of idea. So instead of expanding everything, because x plus 3 we cubed, we would have to expand 3 times. It's a little tedious. And then for the next example would be 4 times, right? So instead of like expanding that, what we're going to do is we're just going to rearrange and solve. Okay, so for x-intercepts, what we do is we sub in y equals 0. And then we just solve for x. So this is going to look like 0 equals negative 2, x plus 3 cubed minus 16. Let's bring this negative 16 over. We get 16 equals negative 2, x plus 3 cubed. Let's divide both sides by negative 2. 16 divided by negative 2 is negative 8. And we get x plus 3 cubed. Okay, so at this point, we have a cubed on the right-hand side. What we want to do is we want to get rid of that. In order to reverse the cube, we'd have to cube root both sides. Okay, so the cube and the cube root go away. And if we cube rooted negative 8, I believe we get negative 2. Yes. Okay, negative 2. So because those go away, we just have x plus 3 on this side. We can go negative 2. We can bring over the 3, it becomes -3. And we get x equals -5. Okay, so taking a look at this, I'm thinking, okay, x equals -5. When we cube root something, we don't have that plus minus option. We just straight cube root it. So just to check our answer, if you go on Desmos, I'll make this smaller. There we go. There we go. Okay, so this graph does only go through the x-axis at one point, and then it, which is right here, -5, and then the squiggle happens here. The point, I shouldn't call it a squiggle, I should call it a point of inflection happens here. Right? Point of inflection from going concave up to concave down. Okay, so for B, y equals 4x minus 8 to the 4 minus 64. So again, to find the x-intercept, we sub in y equals 0. So we have 0 equals 4x minus 8 to the 4 minus 64. Okay, bring over the -64, it becomes +64. Write out the rest as it is. Divide both sides by 4. Okay, 64 divided by 4 is 16. So we have 16 equals x minus 8 to the 4. So we have to get rid of this 4. That means we have to 4th root it. By the way, a 4th root, you can square root twice. So if you don't want, I know a lot of you guys have this button on your calculator, and you have to put a 4 in first, then the button, and then the number, and it's sometimes uncomfortable. Well, you can just square root. So as an example, if you were to take x to the 1/2, whatever x is, that number, which in our case is 16, right, to the 1/2, and you take that answer and you raise it to the 1/2 again, what's going to happen is, if you remember power to a power, is going to be x to the 1/4. So you can actually just hit square root, equal sign, square root, equal sign, and you're going to get the same answer. Okay? So that's just some calculator work on the side. So what is the square root of 16? It is plus minus 4. Remember, if we take negative, I did the square root. What is the 4th root of 16? Plus minus 2. So if we take -2 times -2 times -2 times -2, we are going to get the number 16. It is going to be positive, so that's fine. So there's going to be 2 answers here that we have to evaluate. Okay, and that's going to be equal to x minus 8. So here are the 2 possible solutions. We're going to bring over the -8. We're going to have +2 plus 8, and then we're going to have -2 plus 8. Okay, so we're going to have 2 x-intercepts. They are going to be 10 and 6. And if we were to take a look at that graph, we do have the graph of a quartic function, and we go through 6 and we go through 10. Determine the equation of the transform function on the graph below. Okay, so I'm going to start with that kind of like the vertex form if it were to be a quadratic. So y equals a x minus d squared plus c. I'm going to start with that. So d comma c is going to, it's not squared, it's cubed. D comma c is going to be that middle number, that point of inflection. Okay, so in this case, it's -4 comma -2. So let's go ahead and sub that in. So the -4, because there's that built-in negative sign, we're going to go +4 and then -2. So that's going to be dc. So the point of inflection is going to be in the form dc. Okay, we don't know our a value, which is very, very similar to the questions that we did yesterday. Okay, so that's what we have so far. We can sub in any value for x and y, so an ordered pair just means x, y, and then we can solve for a. So if we try to find a point that's directly on, I want to say the grid, okay, we can find this point. I get -5, 3. So 3 equals a, -5 plus 4, cubed minus 2. And now we go through the motions and we solve. So -5 plus 4, I get -1, cubed minus 2. Okay, -1 cubed is still -1, so it's -1a, or -a, and then we just bring down the -2. Okay, bring the -2 over, and we add it. So I get 5 equals -a. Okay, divide by the -1, I get a equals -5. Okay, this does ask for the equation, so we can then say, therefore, the equation is y equals -5x plus 4 cubed minus 2.